Let's go now as a second chapter into the more, say, theoretical structure of pixel planet and of this kind of processes of standardization and combination or recombination. The research part, the second chapter. I take you back to the function mixer. Funny instrument where we made this say software where we divided the built area in different say units that could that have their own say element, and we described that they could position in something by describing the facades, the nodes on the facade. Every function has some kind of laws in terms of acoustics, etc. And if you do that, the program can say adapt that through these different sliders, can sort the pixels, the functions, and create the best say combination. How much variety, how much concentration, how much environmental input is it there, and that can be checked and evaluated over time. And I still love it because, for instance, if you do right diversity as a wish, then this is the algorithm behind it, because it says maximize differentiation. It's not so complicated. So this is what I gave to Herman Hertzberger. Finally, I digitized you. So that was still one. It was his birthday gift when he became 7. So here you can see the process a little bit. How about diversity, construction costs, and everything goes down, of course, immediately. This is with light, then it sorts out to a certain angle. This is with noise that comes from a certain other part, which is protected by this cloud. So here, how these things are operating while you do it. And now you can much better do it better. But still, I love it in its simplicity, what it is. You apply it on an area in Almere, where they want this kind of, and how that could look like in the standardized matter, how it would form this wall towards towards the highway, while keeping pockets of openness. And then you connect it basically with a software that indicates the facade, the amount of light, the amount of doors, the amount of balconies, and you get this out of that. That was the sequence that it was. The second step was the region maker. And so if you make bigger, like housing areas, then you have to deal with more elements, with hydrology, with vegetation, with topography, with social systems. So what this shows is that you can filter that out on different levels. You can do that on the level of a house, do it on the level of a neighborhood, you can do it on the level of a city, of a region, and of a nation. Like normally now we are going through our data systems, this kind of scaling, this grouping in that way. This information is gathered in this way in the software, and then it can be applied, this grouping pixels, into this operation. So here you open it, you check where you want to be there. You're next to the Netherlands. You zoom in, you pixelize, you analyze the different, say, components, programmatic components of the current, say, cityscape. You group them in order to understand them. You compare them with other parts in the world, and you start to visualize that in different ways. Then you start to work on the properties of it. What can they combine? And you start to show it in the perspectives. And then it can be make this comparative, say, maps between the Ruhr or between Barcelona and here how scores can help to look for the aims. Scores are connected with targets, efficiency, costs, climate demands, targets in terms of speed, etc. And that leads to different, say, validation of the parameters. If you then go into the map, of where it can be placed, there are of course many, say, parameters that limit you, for instance, unemployment or costs or economics, and that are positioned in this. So there's more of that in KM3 to look at it, and that are positioned in a very still primitive way in those days. This is of course complete vintage, but leads to this, say, positions. And here you see how due to these targets that you do, you optimize. In this case, the Rhine-Ruhr city with its parameters into a beautiful city. What is next? Behind the region maker, we start to make to the space fighter. I started with that. So here we pixelized for a moment, the whole planet to see what we can do. It becomes more complicated because there's climate elements involved. There are all kind of, say, also the units come back from the function mixer. It's too detailed to go through it now. Also, there's a whole book on that, the space fighter here in the library to look at it, what that can be. It follows then global projects. So imagine that we want to use our pixels for greenify the edges of the Sahel, or if we want to analyze a reaction on cloud forming of the world, where can we, how to encourage that, or how can we make more water-based sense? That can be put in and put then the pixels over there. So here I see a zoom, take you there. This is Dubai. That is the moment if it becomes a little bit better. It optimizes again this mix of of elements. Here, how port activities or trade activities in the global network can help Dubai or not, depending on the scenarios. You get ghost towns or you get new towns. So it indicates the program, filters it out, it mixes it, and makes therefore suggestions of that. That's the biggest scale. At MIT, this is done in their software, which is accompanying that. So what is next? Let me go back again to another research, Porosity, book that some of you might have read, and is also allowing to add other logics than only the standard stack of pixels. So it is about the current solidity. And you see towers in the whole world like this. They are all the same, and the architect can only do a little bit about the facade and a little bit about the crown and the entrance door. Actually, they're super stupid towers because they have no intention to communicate with the world or to be adaptive or to be to touch each other or to go further. Yes, they are rigid, monotonous, generic, repetitious, divisive also, and closing and segregating due to that. So that we could, the next part is to open this solidity for daylight, for views, for cooling, for ventilation, for greenness and accessibility, for in-between spaces, and for publicness. So there are many people that have discussed porosity as an important element. And I tried to stop Richard Sennett has 2 books on the open city that is say. I think this takes, it's hard to hear about this. But these are some fragments. But also others like Paola Vigiano, good urbanist from Italy. Also, she wrote a nice book on La Ville Poreuse, the porous city, to open it up for that. And engineers are working on it. Here an example, the Arabs' contribution to openness in Milano. So what is next? So how to make that? We did an experiment on porosity. That was by first opening up towers. So if you have a stupid tower, then look, you see one thing popping out, a Lego block in this case, that could lead to beautiful, say, changes. These are sequences by one student. Every student makes one sequence, or you can pop out one thing here, one that opens up gradually, step by step. Each one, bigger one, bigger one, bigger one, bigger one. So like a cracking tower that opens itself, or you cut, another student cuts it and lead to the amount of windows that you can get out of that. There was a student that twisted and studied how much can you twist it to the structure and the light to that. There were students that grouped it and made like collective spaces in this kind of balloon-like structure. There were students that cut it like cactuses so that washing lines could be between the towers at that moment. And that leads then to like a series of one step to 20 of towers next to each other. We call that post-scripted because the students started with an intuition to make them together. Like here, how it can cascade, turn into stairs. Here, how it can maximize the interior. I explained that before. These are all steps that are then done in these proposals and based on, say, choices, which are, I think, nice because every tower has a personal touch. Here, the three-dimensional courtyard. Here you see the search for the best skin in a way that leads always to a ball or a sphere in a way. Or here, how it can turn into steps and then to a balancing tower, very polite one, bends to you in that way, or to this Jenga, technology in that way. So what is the next? If you put that together, you get this kind of, say, spaces, like a city of science almost, of comparative elements, an expo on it. And I still dream to have such a kind of city somewhere where you can show the differences because of this. This is nicer than Manhattan, and or definitely than Heidegger, his example on what you can find then in this city. Even Frank Lloyd Wright was there. So what is next? We made pre-scripted towers. So from post-scripted, because here in post-scripted you start into intuition and you make a sequence, but actually they have an order. That leads to a sequence, that leads to a script. So that in the pre-scripted you first analyze what you want. You have sliders about height, weight, and the aims that you can do, and then study this. Same in envelope. Here you see, I want to make a landscape tower, so you make floors, you bend the floors, and then you have grottos that interconnect. That leads to a beautiful tower. If you add structure to that, you get this. If this is a stair maker, so the units used for in the boundary, in the envelope, to make these stairs, and that leads to a tower which is more beautiful than Escher ever have been doing it. Or the terrace maker, so it is more like developer oriented, so it's easier to make. Or the concentrator, or it's also beautiful here. Surprise came in it. So here cavities were designed as such with bubbles, smaller and bigger ones. They touch. You have to make then that they kiss these bubbles, and you have to organize diversity. And actually, it is a fantastic tower that can be done made out of these pictures. What's next? So here you see the images of that exhibition we made, and we're hoping for here to do a similar aspect in a way, how that could lead to this kind of richness of encountering, and how it's here exhibited at a certain moment. So what is next? About cityscape. How can we do that? Urbanism. Here this is a famous, say, map of studies of Ungers and others in the 80s to show the different patterns of urbanism. You see that cities have different morphologies, other ways of living, because of climate, because of background, because of history, because of priority. Some cities love small streets, others want big streets, and want to order it differently. That has to deal with also other ways of living. Here you see an urban villa. This is a Dutch block. This is a Barcelonese block. This is Russian. This is Parisian. This is Voisin. This is Hong Kong, Manhattan. So what is next? If you have this density, these are all the pixels in, say, 200 by 200 meter. So what can I do on that? So if you, for instance, base it on patios like this, we can improve the patios by making terraces like that. And then the others become grottos. What is the effect of that process that we then are doing? We see the section that emerges. We can do that also by, say, this kind of slabs. How can we improve them? By bending them to each other. They create more balconies, more views, more connection. So not bad. Or this project, another patio opens up and emphasizes the crossing points with meeting points, the collective space. Also not bad. So what is next? Here an example of towers that somehow bend to each other, seek connection in different steps. Also quite good. Or what is next? Here you see the pyramid structures that help. If you increase certain aspects, they become to this kind of stalagmite city, gorgeous city, hidden city. What is next? You start with random patios, make them into bigger bubbles up to the moment that they are on the size of a connective, say, city. Then actually you make New Babylon by Constant Nieuwenhuis in the end. And then you can measure it. This is a normal block to compare with its properties. How much terraces it has, how much corner views it has, how much stairs it has, how much collective spaces it has. And that you can then compare with these new examples, how they score on all this. How this category does that. How these kissing slabs perform. And actually they're all better than the standard for all this kind of elements, and I'm aware. This is selective, that can be added to it. But systematically, I think it was an interesting exercise. So what the net, you get this kind of, say, cities here under construction, how this region of cities was exhibited and showed these elements. The nice courtyards, the open gathering points, the kissing slabs, the crossing, the leaning towers, the ascending towers, and New Babylon. What's next? Costs and benefits. I immediately client saying that. So let's do that. The next exercise. So you see a sequence of, I don't say that anything's being on video because this is development. But in this case, there was a second studio with technicians to make, in this case, steel towers, prefab elements, and check what would happen if you do these operations on it. So what can you do? When you see, you compare the, you can calculate the daylight, the cooling, therefore, of these guys. We can, for direct sunlight, test that. We can see the extra terraces and outdoor spaces it gets. We can check the views to each other and to the neighbors. And then the structure, of course. So in blue, it's say a certain tension, and in red, it's of course more tension. And that leads to, from the left to the right, of course, to elements that you have to solve. It costs more, but the benefits are extra terraces or extra cooling. So here also an analysis, it's not so expensive. Of course, this blending guy is quite expensive. Politeness costs money. That's what I actually would like to say. Here it's local in this operation. Here the needle, which I'd still love to make somewhere on the world with a direction, would be, of course, has some issues on the ground. This is also a nice exercise. You started bending, then halfway in F3, actually it becomes expensive, and then it bends back again and becomes a Roman arch. And that was the base. This was the analysis of the market hall in Rotterdam, in that way, to make it, to show that it's actually cheap. So the default tower, and here what happened when you start changing that to this these elements. That leads to numbers of, and then to validate these numbers, and that leads to comparisons. So this map shows the combination of different scores of, in this case, daylight or costs, and how that can be combined. So sorry, it's a bit deep. Maybe some of you are bored about this, but it's I think this is, we're entering a master education. So what is next? I'm very happy that the Centre Pompidou bought it, the research, and that is now in a permanent collection of that. So these elements somehow say something in the world. You make books, but you get pieces out of that. And I think actually the studio that we do now come out of it. Of course, one of them, the things that I wouldn't like to do in the future, not to use Lego in the manual way. I think that's it took 3 students 3 weeks, day and night, to make one tower, and which is like slavery or something like that. So it is so this is a project done with UCLA to transform their robot with a pusher so that Lego can be automized in that way. Lego was not amused by it. It was to have that organized. So what is next? Of course, we dreamed then also about a porous planet. When I made this, you see this Bali ball that some of you might know, which is carved out coconut. But in a way, that's how the crust of our planet will act in the future. Down and up. Down for mining. So how far are we going to do that? Or connections like tubes that connect the cities, metro systems. Up and down for water, not too much. Up for density and for cloud forming. So that leads to I think, a new extra planet as such. Here, the Sky City project plays a role in that. And if this goes quick. I think it's, there it is. This was, of course, a project for Sky Angeles, the Angel Town, which is based on, On patterns, so you see how these units, when it's 7 o'clock in the morning, most of the people sleep. So all the activities are analyzed in this case by pixels, and they move over the day. And I still love this film because it's like showing how when we do what. Second step is what do we leave behind? So imagine that you always are in your pixel or car. I won't plead for that. Then this would be the new clusters over the day. You come together on a school, you cluster around it. These are the potential programs of this pixelization as in that way. If I go further to the objects, here I think that touches now about what's part of the what needs to be deepened. That's basically what is the size of the pixel. So here on the right side, you see the smallest one is my body. What can my body do? I need to cook or I need to go to a bath. That leads to bounding boxes. There's a combination where it's a perfect optimization to make that. So this architecture, sky architecture or movable architecture, is leading based on these modules grouped into this kind of what we call pods of activities, then goes into an object, say the house or the school, that come to come together, and then into certain kind of hybrids over time that are clustered with that. Hope you understand that, because that's kind of important part, because here you see a key how maybe a structure can come out of this pixelized world. And important is attach and detach. Of course, that's a detail, which is hyper pragmatic, cars, flying, bolding or not bolding. What are these pockets that we make them? And then it has some advantages that circulation, for instance, adapts itself. Where is my stair? Do we prefab that? Initially, yes. A lift also. In the future, maybe it adapts itself. So this is nice to compare them, to have a transition over time of the stair or of the lift, what it can be. So we have a pod maker. That's one device that is seen here. Here are the elements of couches, circulation. There are connection rules that come into it because, yeah, pipelines have to connect and conduits have to connect in that way, but also certain logics. I go from my bathroom, normally to a toilet, or first toilet and a bathroom, and then to my dressing closet. So that is could be somehow, and that leads to the object maker. So from the pod to the object maker has to be accompanied with a wish list of elements, and then to aggregation rules. Entrance connection, the wall connection is an important one. Top, bottom, what is the relationship between that? So this is an advanced function mixer. Because, 10 years later. Research takes 10 years, what it indicates in a way. And also the position of the windows that can be then flexible. So here you see a pod forming a process on how a school would function during the day and how to collect students and change its program. That leads to, for instance, here an apartment building, an office building, and also a park, could be imagined in this case. What are the components of park making? That can be mixed in this case. So there are, of course, conditional rules of making this. That is the daylight, explored before, neighboring relationships. There are design reflections on that to imagine. Go slow, sorry. I guess it's heavy, this file. Here it is. And here you see some simulations on how it is. Here, one user with his bathroom, all those kind of elements, where it positions itself. It becomes more interesting when there are 46 users, or 46 students at that moment, and how they would go over time, how that would cluster it. It's good, and then if there are 2,500 users, somehow we are there. We will be also working on 1,000 units somehow to make this out of this in order to give this density. So what kind of forming does that have? What are the factors that dictate that? is what this mini film is showing. The search, because in the meantime that it's searching, it's actually checking parameters and killing the ones that don't match in that way. And this list, this check of 1,000 is what this software does. And then I think you get a kind of sky city of like this. I go to this, it's a better film. How that. This is too primitive. And it's a year old, but it's vintage. It doesn't show the forming of it. So that is, I think, indeed intriguing how we can visualize the coming time. And in a more profound way, this juxtaposition, this transformability. Maybe we have to concentrate a little bit more on a smaller element. See how that flocking and unflocking can be done. And these are some of the images for that. So what is next? That's you.